let us discuss about what refraction at spherical surface. Refraction I am talking about. Before that, yesterday I just forgot to mention one more natural phenomenon we observe in our daily life. Actually, we need to observe in our daily life, so-called mirage. Mirage. Mirage means in Kannada, Maya Mruga, or is also called what, like in our Kannada textbook it is given as marichike. Yes, the right word. Marichike or Maya Mruga, or there is one more term this for this mirage. Okay, what is mirage? Where we observe it? This mirage is purely due to total internal reflection, and it is usually observed in summer season, hot summer season. That's true in deserts, marubhumiಗಳಲ್ಲಿ, in deserts like Thar. Thar is one desert. There is one more desert, Sahara, right? Where we observe this mirage. Okay, Bisal Gudre, Marichike, all those things. In our daily life, here, whenever, okay, in a hot summer day, if you are walking along a highway or tar road, or you are moving in a bus, traveling in a bus or car or a bike, you observe at a certain distance patch of water. At a sunny day, very hot day, when temperature is very high, we observe on highways. ಹೈವೇಗಳಲ್ಲಿ ದೂರದಲ್ಲಿ ಒಂದು ಯಾವುದೋ ನೀರಿನ ಪದರ ಇದ್ದ ಹಾಗೆ ಕಾಣಿಸ್ತದೆ. ನಾವು ದೂರ ನೋಡ್ಬೇಕಾದ್ರೆ ಅಲ್ಲಿ ಪದರು ಹಸಿರು ಆಗಿದೆ, ನೀರಾಗಿದೆ ಅನಿಸ್ತದೆ. ಆಕ್ಚುಲಿ ಹತ್ತಿರ ಹೋಗಿ ನೋಡಿದಾಗ ಅಂತ ಯಾವ ನೀರಿನ ಅಂಶನೂ ಇರೋದಿಲ್ಲ. ಇಟ್ ಇಸ್ ಆಲ್ಸೋ ಡ್ಯೂ ಟು ವಾಟ್ ದಿಸ್ total internal reflection. Now, it is given out text. What is mirage? Say it is some tree. In desert, what you have usually dates, correct? Dates. Let me like some tree it is. Okay. See. Okay. During summer season, hot day, air. I'm talking about air. Air near the surface of earth, near ground, gets heated. It's very hotter. If imagine there is no current of air, flow of air fast, then air layer which is very near to ground is very hotter. It's get heated very fast. And this air makes what? Different layers. Very layer again. The second layer may be less hotter. This is not very hot. As compared to this is little less hotter. And this third layer may be little what? Less than this layer. This layer will be okay. What I meant to say is this is hottest layer, this is hotter, little hotter. Likewise, temperature or the temperature what decreases as you go up. If you move like this, the first layer which is very close to ground is hottest. Second layer will be little cooler than this layer. This layer will be to some more extent cooler. This layer will be similar. In this way, there is a variation of what heat or hotness of these layers. This layer, which is hotter, is having a less density than second layer. This cooler layer has higher density. Next layer has one more higher density. Here, as we move from upper layer to downward layer, different layers there, refractive index of these layers decreases gradually. The refractive index of these layers decreases gradually. Or the refractive index of air is directly proportional to density. If your layer is more hot, then its Ri will be less. This layer having very less Ri refractive index compared to second layer, where there is increase in refractive index. For this third layer, yes, there is increase in refractive index. For fourth layer, there is increase in refractive index. Refractive index increases gradually as you move up. Hope you understand. Or whenever a light is allowed to, see, this is ray of light, allowed to fall on these different layers. See, this is most denser compared to this layer. This is denser compared to this layer. This is denser compared to this layer. Correct? Here, your light ray of light is traveling from what? Denser to rarer medium. Denser to rarer medium. If layer is most hot, then its what Ri will be less. Every time it will draw here, a ray bends away from the normal layer to layer. Layer in the layer again layer in the layer again, your ray of light will bends away. Why? Why? Because as the ray of light is traveling from denser to rarer medium. Here see, once again it bends away. Once again it bends away. At some layer, if angle of incidence from this object, say tree, is greater than critical angle, then the light will what? Reflect into same medium. Into same medium. Right? Reflect into same medium. A person standing at some distance will see this light as light travels in straight line. What he observed? He observed inverted image of this tree. Inverted image of this tree. It's a optical illusion. Optical illusion. Optical illusion. Illusion means conductor too. Optical illusion is produced. So that inverted image of this tree is produced. Light seems to be coming from bottom of the ground or from the sand, producing optical illusion such that there may be some what? Pond of water, there may be some water. And we are seeing the person, we are seeing the image of this object, this tree, in the pool of water. Pool of water. When actually we go and see there, we observe what? Then definitely there will be no water or any such thing. This is an optical illusion produced due to increase in the hotness of the air layers and decrease in what? Refractive index. This is mainly due to what? Mirage is mainly due to total internal reflection. This is the thing I have to, okay. Yesterday class I forgot to mention. But today's class, what we have to discuss? In today's class, we are supposed to discuss what? Refraction at spherical surface. Okay, let me write. Refraction at spherical surface. What is spherical surface? Simple. It's a part of sphere. A part of sphere is called spherical surface. A part of sphere is called spherical surface. Okay? This is a what? Transparent spherical surface where light once allowed to fall on this surface will undergo what? Refraction. Process called refraction. Let us consider a spherical surface. A spherical surface. A spherical surface. See, like this is a part of a sphere. Part of a sphere. Simple thing. We have studied all these things. Let us consider a spherical sphere, spherical surface, and let this point to be, and a straight line passing through P, called principal axis. This is the principal axis, correct? And here, I will copy this one. Let us consider a point object, a luminous point object, luminous producing light, point object. See, this is point object, producing light. A ray of light is allowed to incident on some part of this spherical surface, say M. Let me tell you two more points. Point number one, all the laws which are applicable, all the laws of refraction are equally applicable to this surface also. Your laws of refraction are applicable to this surface also at any point. The curvature of this surface is very small. Like your test tube in chemistry, what? They have used test tube, no? Right? This aperture is very small. Second point to be remembered. Point number three. All the rays we have considered in this derivation also are paraxial rays. We have to consider only paraxial rays. Whatever angle made by these rays definitely are very small. They make what? Very small angle with the normal. Point number 4 or 3. As this curved surface, of course, refracting curved surface, similar thing, we can draw normal at a point of incidence such that the normal must be perpendicular to tangent. The normal must be perpendicular to tangent drawn at this point. All these things we have studied in our previous classes. Correct? While studying mirror. Correct? What? This is an incident ray. We get somewhere here reflected ray, refracted ray. To get angle of incidence, we must draw a normal. We have to draw a normal in such a way that it is at the point M and it will meet at point C. And C is called center of curvature. Where C is called center of curvature. Okay, let me draw this thing. I will draw a normal. This is point C. I will draw a normal. particle very small, your MP is almost straight line perpendicular to principal axis. It's perpendicular to principal axis. It is not a curved path. It's almost planar. A small portion of the curved path is almost planar. It's like a straight line. And after refraction at this point, the ray will produce some image here, I. Image of this object is produced somewhere here. This is incident ray, this is refracted ray, this is normal, this is perpendicular. A normal is drawn from point M towards the C, where C is center of curvature. C is center of curvature. Here we have two refractive indices. Indices, plural. Let N1 be refractive index of object space. What do I mean by object space? Where object is kept. Let N1 be refractive index of object space. And let N2 be refractive index of image space. Correct? Now, for convenience, let me take this angle as alpha, this as beta, and this one as gamma. Let us see. Now, this is a refracted ray, this is a incident ray, this is a refracted ray. This angle between incident ray and normal is angle of incidence. Very easy, you know this. This angle between refracted ray and normal is R, angle of refraction. This is the construction of what? A spherical surface. This is spherical surface. Set XY. XY spherical surface. O is a point object, luminous object, placed at a distance U from pole, midpoint of this spherical surface. Let V be the object distance, the image distance. Let V be the image distance, let V be the image distance where image is produced. And from P, what we have got? This distance. This distance will give you what? Radius of curvature. All the known things. We know all these things. Now, in exam, this question will be asked in this form. क्या फॉर्मूला क्या होता है? Derive the relation between U, V, N, and R, where symbols have their usual meanings. Very interesting question, right? Derive relation between U means object distance, V means image distance, N means refractive index, and R means what? Radius of curvature, where these symbols have usual meaning. This is type of this will be a question. Or derive expression for object distance and image distance in case of spherical surface in terms of radius of curvature and refractive index of the medium. refractive index. This is one more way to ask this question. Please remember, this is very important question. For 5 marks. Let me mention this, right? Very important. Very important. 5 marks. Very important. 5 marks. I hope no problem in this figure now. You can understand this figure, right? Now, only this much area I have now to derive this quite long derivation. Anyway, we will do it. Very easy derivation. Initial expression now. Let xy be the spherical surface with radius of curvature r. Let O be the luminous point object placed in an area of refractive index n1, placed in a space of refractive index n. Let n2 be the refractive index of image space, where image is formed. Let n2 be the refractive index of image space. Let u be the object distance and v be the image distance. Okay, this initial explanation is enough. Now, from triangle MOP, from triangle MOP, if you consider tan of the angle, tan, this is 90 degree, this is alpha, alpha is tan MOP, which is equal to what? We have taken MOP as, to avoid confusion. Every time I write tan MOP, I will write it as tan alpha. Tan alpha is equal to opposite C, MP. Why MP? MP is not at all curved path. It is straight line. It is straight line. Straight line. Perpendicular to the principal axis due to parallel rays of the things. NP divided by SN. OP. This is equation 1. No. This is the okay. This is as these angles are very small. This M and P are very close to each other. Angle made by this incident is very small. We can take tan alpha. We have done in previous derivations, right? I have just approximated tan alpha is equal to approximation. So, therefore, alpha is equal to MP by OP. Correct? Now, as a triangle exercise, from triangle, say MCP, again MCP, once again right angle triangle, tan MCP, which is equal to visible, right? Tan, we have taken it as gamma, right? Tan gamma, once again same formula, opposite by SI. That means MP by PC. Correct? Simple. MP by PC. Similar approximation, and this the tan gamma is almost equal to gamma. So what we get? This will be gamma equal to MP by PC. Equation 2. We have one more triangle here. MIP. What? MIP. From, once again, write a triangle. MIP. Tan of the angle MIP, which is equal to tan beta. What will be equal to what? Opposite. Say this angle. इल्लिंदा होगी, ये होगी, ये MIP. Correct? Tan beta is equal to MP divided by PI. On similar approximation, this tan beta is almost equal to beta, then I can write beta is equal to MP divided by PI. Equation 3. We have three different equations for alpha, beta, and gamma. This is equation for alpha, correct? This equation for gamma. This equation for beta, correct? Now, okay, I'll write here. From triangle MOC, ಎಲ್ಲಿ MOC ಇದೆ ಇಲ್ಲಿ ನೋಡಿ MOC. From triangle MOC, ಈ ತರ ನೋಡ್ಕೊಳ್ಳಿ, ಕರೆಕ್ಟ್ ನೋಡ್ಕೊಳ್ಳಿ. This eye is exterior angle, ಬಾಹ್ಯ ಕೋನ. This eye is exterior angle. ಯಾವ triangle ಅಲ್ಲಿ? Let me repeat. MOC. ನೋಡಿ, MOC. In this triangle, this eye is exterior angle, ಬಾಹ್ಯ ಕೋನ ಆಗಿದೆ. This exterior angle is equal to sum of these two interior opposite angles. This exterior angle is equal to sum of those two opposite interior angles. Then I can write from triangle MOC what? Your eye will be equal to what? Alpha plus gamma, I can or gamma. You can avoid this alpha, gamma, all those things. You can directly write I is equal to angle MOP plus angle MCP. This is also correct. But every time you have to write quite long expression to avoid, just you can write what? Alpha plus gamma. This is your request. Okay? Let me give number equation 4. Now, from triangle MCI, look carefully, very important. From triangle MCI, see here, MCI. This is M, this is C, this is I. MCI. 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 Which is exterior angle here? Now the exterior angle from triangle MCI, this gamma is exterior angle. This gamma is exterior angle. Gamma. What about two opposite interior angles? This is exterior angle. These two are opposite interior angles. Ergo, this is gamma will be equal to what? R plus beta. Hope you understood. This gamma will be equal to R plus beta. This is very important revision. You have to what? Practice it. And first try to understand it. Very easy derivation, quite long, that's all. No problem, quite easy. See, this is gamma will be equal to what? R plus beta. This is exterior angle. These two are what? Interior opposite angles. Triangle is MCI. So gamma is equal to R plus beta. Let me take this R outside. What will R is equal to, send this beta here, gamma minus beta. R is equal to gamma minus beta. Say equation 5. Now we have 5 different equations. This is equation 4. This is equation 5. This is equation 5. Correct? Now I'm finding space to write now. Otherwise, we'll get confused. Okay. I will write all the equations here first. Okay? Somewhere here. They are visible. This is value of alpha. Alpha is equal to visible. Correct. Alpha is equal to MP by OP. Say equation 1. This is beta. Beta is equal to MP by PI. This is equation 2. Correct? Yes, where I have gamma or gamma. Gamma is equal to what? MP divided by PC. Equation 3. Now let me clean the board. Okay. Now, we know what? We know N1 sin I is equal to N2 sin R. Correct? Where? From where we get this equation? We know N2 by N1 is equal to sin I by sin R, which is nothing but Snell's law. Or we can simplify it as N1 sin I into N2 sin R. In the class correct some points related to refractive index where we have mentioned this n1 sin I is equal to n2 sin R. Okay, as angles are very small, we can write sin I almost equal to I and sin R is almost equal to R. That's why we just created two equations. Where one equation starts from I, other equation starts from what? R. We have two equations, I and R. So that we can put these two equations, the values of these two equations in this equation. Snell's law equation. So I can write this as N1 simply I is equal to N2 R. So equation 6. Now you can put value of I and R from equations 4 and 5 in this equation 6. What we get? We get N1 in place of I. This is I. Don't confuse. This is I. In place of I, let me write alpha plus gamma square. Alpha plus gamma is equal to N2. In place of R, let me write gamma minus beta. Correct? Correct? What we did? We just considered this equation. Equation equation is N1 sin I into sin R from Snell's law, and once again we made some approximation where this sin I is almost equal to I, sin R is almost equal to R. Sin I is almost equal to I, and sin R is almost equal to. By this approximation, I can write N1 I is equal to N2 R. If it's so, I can put value of I from equation 4 in this equation as alpha plus gamma is equal to N2 into R, value of R from this equation as gamma minus beta. Up to this point. Next step. Okay. Now, let me use this space now. Here, value of alpha is, see here, N1 into bracket, this is alpha, here we have value coming from, this is value, alpha square by what? MP divided by OP plus, what about gamma? MP divided by BC. MP divided by BC is equal to N2 gamma once again. MP divided by BC minus sign. Visible? Minus sign. Beta. MP divided by PI. Correct? Very good. Now, we can cancel this MP, and simultaneously let me multiply N1 inside the bracket. N1 inside the bracket. So, what we get? N1 by OP plus N1 by PEC is equal to N2 by PEC minus N2 by PI. Correct? Correct alva? Correct alva? Just multiply N1 inside that square bracket. So this is the equation we get. What next? Okay. Here we have BC and BC, common denominator. So just transfer this N1 this side and bring this N1 into this side. So what we get? I'll write here. N1 by OP as it is. Bring N2. In negative is each other automatically what we do? It's positive. Plus here is then minus. ಇಲ್ಲಿ ಬದಲಾಗದು plus ಆಗುತ್ತೆ. Then N2 divided by Pi is equal to N2 ಅಲ್ಲೇ ಇರಲಿ. ಇದರ ಆಚೆ ಹಾಕಿ automatically it's negative. Let me write N2 minus N1 divided by common denominator PC. We can write, or you have to write one step and then you have to write this step. Correct alva? We can write directly common denominator PC. Now We have Cartesian sign conventions, correct? We have what? Cartesian sign conventions. Those Cartesian sign conventions are equally applicable to, are equally, one second. Okay. They are equally applicable to this spherical surface also. This spherical surface also. We have Cartesian sign conventions, correct? Those Cartesian sign conventions are equally applicable to this spherical surface also. Why we are discussing that? See, here we have OP, this is PI, this is PC. What I mean by OP? OP is nothing but your object distance. OP is nothing but your object distance. What is about PI? What's about PI? PI is nothing but your image distance, V. OP is U. What about PC? PC is nothing but radius of curvature of the spherical surface. Radius of curvature of the spherical surface. Let me put these values with the sign convention. Okay. So N1 divided by OP, object distance. All the distances must be measured from pole of a mirror. Start measuring this from this point. And second point, second convention. If you measure in the direction of light, then take it as positive. Opposite direction, take it as negative. Your ray of light is moving in this way, your ray of light is moving in this way, and you are measuring it in this way. So, opposite you are measuring it, correct? In opposite direction you are measuring, automatically it will be minus Q. Hope you understand. Hope you getting right? No problem in that. Plus, N2 dot of PI. PI is nothing but image distance. You have to start measuring from P in this direction how to move, and your ray of light is also moving in this direction. See, both are moving in this direction. You have to start from this line, both are moving in this direction. So, automatically, your P is positive. Your P is positive as it is in the direction of, what? Ray of light. What about N2 minus N1? What about PC? This is PC. Once again, you have to measure from P and you are moving in the direction of P. You have to measure from point P, and you are moving in the direction of, what? In the direction of light. Hence, R will be positive. But R is also positive. Finally, what we get? See here, N2 divided by U minus N1 divided by U is equal to N2 minus N1 divided by R. This equation gives you relation between U, V, N and R. The equation again it gives you relation between U, object distance, V, image distance, N, refractive index, and R, radius of curvature. Correct? It seems to be big, but easy, no problem with that. Easy आगे mark. Then remember. This is very important equation. You have to use this equation in next derivation, which is one more important derivation in our chapter number 9, so-called lens maker's formula. While deriving lens maker's formula, this is a base equation. So, this is important equation for next derivation. Please remember. Now, how to remember this? V is a image space V is image space, U is object space. Correct? V is image ಇದೆ, O U is object ಇದೆ. Refractive index of image space, word by word, let me repeat. N2, refractive index of image space, yes, sorry. Refractive index of image space divided by image distance. Refractive index of object space divided by object distance. Refractive index of image space divided by image distance minus refractive index of object space divided by object distance is equal to difference n2 minus n1. See, this is n2 minus n1. Can we get n2 minus n1? n2 minus n1 divided by radius of curvature. Difference is in RR. This is how you are supposed to remember this. Again, refractive index of image space divided by image distance minus refractive index of object space minus object distance is equal to difference n2 minus n1. That's why I am trying to here n2 minus n1 divided by radius of curvature. This is how you can remember this. Okay, one of the most important equation. It's already 46 minutes, correct? 46 minutes. Let me stop the class. Okay. Next class, let us study about lens. Actually, lenses. Type of lenses. Same we have studied already in high schools. Just let us just touch the things like convex lens, concave lens, plano convex lens, plano concave lens, convexo concave lens, concavo convex lens, different types of lenses, and optical center, image formed by a convex lens as well as concave lens, foci or foci. Why we have two f1 and f2 principal focus in case of lens, and rays to be considered in case of constructing image in case of lenses. We will finish it fast, very fast, and then definitely lens makers formula. After lens makers formula, we have to study what? Refraction prism. One more 5 marks question, and two thin lenses in contact. Another 3 derivations we have, 5 marks derivations in this chapter. Then just 2 or 3 marks questions. We will finish it as soon as possible. Thank you. Take care. Bye bye.